Daryl. All right. So we are going to have one presentation today, and then we're going to go into the notes where we left off yesterday, and I fixed my mistake that I had made and caught at the end of class, which had to do with me being completely squirrel-brained and forgetting things. So we will do that, but I'm going to mute my mic and stuff so that way Jesus can share his presentation and talk.
Now?
Yep.
Okay. Well, my name is Jesus Sanchez.
Don't forget your people
I
here, too.
did the PowerPoint about the temporary seasonal forest, which was a deciduous forest. This is a world map of the deciduous forest. Right here in the green areas, we can see that there's a deciduous forest in North America, South America, Europe, and some parts of Asia. They are regularly 20 to 60 degrees latitude wise, and they're around the equator but not too close. Some characteristics: the name seasonal means that they go through all four seasons: winter, spring, summer, and fall. They change color, the leaves change colors in the fall. They get off, they get off or whatever. In winter, they grow in the spring and then they stay for the summer. The plants in this type of forest are fit to survive the cold weather. The temperature averages around 50 degrees Fahrenheit. Mild temperatures in the summer, which are 70 degrees Fahrenheit, and the winter does go below freezing at some points. Annual rainfall is up to 30 to 60 inches, which is one of the highest other than rainforest, not rainfall. Oh, it says rainforest right there. And then there's snow in the winter. What the heck? Am I in presenters mode? I am not, huh?
No.
That would have been nice to know, Miss Peterson. Okay, this is part two. This type of forest has a forest called, how do you pronounce that? Apsals? That's what I found.
Which one?
It's that one.
Oh, yeah, absolutely.
Apsals, which is one of the best and fertile soils, so I've heard, and it does not have an E horizon, but it does have clay that adjusts. The plants tend to variety in three. There's three levels: the shorter plants, the taller plants, and the tallest plants. They're like lichen, moss, ferns, wildflowers. That's the floor level. The taller ones are shrubs and the hardwood trees, and then the trees like maple, oak, birch, Mongolia are the top level. For this part, it's the characteristics about animals and the type of living things that are found. We have insects such as frogs, not such as frogs, insects, spiders, there's frogs, there's salamanders. In North America, we get broad winged birds, whatever, right? Huh? Hawks right here. Then there's a red fox over here, and there's a white-tailed deer right there. This contains the food chain and the food web. The producers are the plants and trees. Consumers are the consumers are the organisms in the next level, found right here. They eat the plants, the seeds, berries, and grasses. Higher up in the food web, we can see that they're these type of consumers that usually eat the next floor under them or level under them, and it just goes on like that. Right here we have this, where we can see the different arrows pointing to different animals, which represents who eats what or who. This is a, how do you pronounce that?
Which word?
The
Climatograph.
climatographs. The top one represents the one in Spain, which is in the southern hemisphere. This one represents the one in the northern hemisphere, which is located somewhere in the northeastern part of North America. The line, I believe, represents the temperature, and the bars represent the rain, the amount of rain. As you can tell, once you start hitting the cold months, they start going down and up. And so the natural resources, there's some type of barks that are used in for medicinal purposes, such as helping with asthma. Berries can be used as a substitute for cranberries. They provide an ideal habitat which nurtures food for us humans to eat. And then we have all these different type of trees, a beech tree, maple, chestnut, hickory, elm, basswood, sycamore, and all this type. And then there are some type of body of water contained around or inside the forest. That's it. How do I don't know how to unmute myself. Oh, there you go.
There we go. All right. One thing I will mention: Spain is not southern hemisphere. It is definitely northern. It's like same latitude.
Huh?
North, south.
Yeah,
south. East, west. North, what?
Oh yeah.
Oh.
I just saw the slide.
Yep. Otherwise, it was pretty good. I did have to laugh at that though. All right. Don't forget that you guys are supposed to be doing questions in that document. You need to do 3 of them. So again, not everybody. So keep working on that. We are going to jump back to the notes today, and then hopefully they won't be too long. Let's see, these ones. Write yourself fast. So we got through this part, and then we got to where I screwed up. So because the little sort thing didn't work out so well last week, I decided not to do the one for this, and then I forgot to take it out of the PowerPoint. So I have updated everything. I have updated everything in the actual section of PowerPoints, so that way you can go and copy and paste it, and you don't even have to type it in. Oops, sharing the wrong screen. Oh my god, now my team shut down. This is fun. Come on. Oh my gosh. Well, I definitely don't deserve it because it's kicking me out. All right. Hopefully this works now. All right, so all of this is uploaded, so you can copy and paste it and then put in your own cycle pictures. This was going to be a sort, kind of like you did last week with the biomes. But like I said, that didn't go so hot, so I meant to skip over that, and so I just filled it in for you guys. Like I said, you can copy and paste it, so you don't have to retype everything into your document. But I am going to go over it really quickly. So you have in this chart processes in flows, which means how do these nutrients and elements move through each of these cycles. The only one that's not up here is water cycle. Hopefully you guys remember things like condensation and evaporation. And so that's how everything moves through. It's the same thing, it's just different names. The one I will probably point out to you, couple, nitrogen cycle gets tested pretty heavily, so nitrification, ammonification, denitrification, and how those go through, which I'm going to have you guys practice today. And phosphorus cycle is the only one that does not go in the atmosphere. So sulfur is in the atmosphere, nitrogen's in the atmosphere, obviously, and carbon is in the atmosphere, but no no phosphorus. I was gonna say hydrogen. There's definitely hydrogen. That's the only one that stays on land. There's hydrogen in the air. Probably, because there would be no water. All right. Stock storages and reservoirs. I don't know why my computer is flipping out like that. Hold on, Leland. So stock storage and reservoirs. When we talk about reservoirs, and it's places things get held onto for a really long time. So like long turnover time of carbon will last in sediments and rocks for hundreds of thousands of years, to where it might only last a day in the atmosphere. So that's what we mean by like storage and reservoirs. It stays there, and it stays there for a long time. For nitrogen, it's definitely our atmosphere, since we're 70-ish% nitrogen that we're breathing in. And then, what is it for phosphorus? It pretty much stays in your rock cycle. It is in other stuff, but again, that's the one that doesn't do atmosphere. And then sulfur's in all living things. Why is it in all living things? Especially if you had biology last year, you should know this. Why is sulfur so important? Sulfur and nitrogen, really. Not far off. Smaller than bones. You're close. What's in the cells? That's really important.
Mitochondria.
In the nucleus, there is DNA. Thank you. I was not your biology teacher. All right. DNA. So sulfur and nitrogen and carbon, and phosphorus. That's a phosphate sugar backbone. They all move through living things. They need to get recycled. So yeah, your sugar phosphate backbone has these elements in it. Some way humans impact are the fossil fuels, the combustion, fertilizers, soaps, are all pretty contaminating. So you can think of that type of stuff. And then, like I said, you guys can copy and paste the cycle picture in there yourselves. You can even use the ones on the PowerPoint. They are a little more complicated, but you're welcome to use them. All right, like I said, this is in the 1.4 notes, so you can copy and paste, and you don't have to type it over if you're typing your notes. I'm going to skip over the practice questions for now, but at least you know you have the answers. And we're going to talk about water cycle for a quick moment. Yeah, whether you like it or not. All right, so water cycle and availability gets talked about a lot, and I've mentioned a couple things in some of your PowerPoints already. Why is it important? You need it for all living things. All right. It also moderates climate. That's why our climate swings up and down like crazy. Like how it's supposed to be 26 tomorrow, 70 on Saturday, and back in the 20s on Sunday with some snow. Yes, Dante, it is in your packet. It's the first thing under hydrologic cycle. But if you're near the coastlines like LA, Sacramento, Portland, Seattle, those ones, they don't have the temperature swings like we do, because that Pacific Ocean moderates their temperature, so it doesn't get as hot and it doesn't get as cold. All right. The water removes and dilutes waste and pollutants. Mr. Delahoy and I actually joke, because we both worked in chem labs before, that the solution to pollution is dilution, because that's how it used to be. Oh, just add water to it, and now you can dump it into the river, no matter how bad it really was. Yeah, that was literally how you don't pollute up until like 10, 15 years ago, maybe even 10 years ago.
Add water to something before you add more water.
Yes. That's how it was treated, yes. Even like things like arsenic and lead and, oh, just dilute it and then you can dump it in the river. That's one reason Fountain Creek was so nasty for so long. Now you know. Let me see. All right. It also moves continually through the hydrologic cycle. I forget who did wetlands in here. Wetlands are a big part of water. They're a nature sponge. They do actually filter out contaminants, so that does help, and then helps move things through that hydrological cycle, especially through plants and animals. I was hoping that would work. It did not. That's true. All right. Can I move on?
Yes.
Thank you. Oh, Leland, I forgot about your question. Did you still have one?
No, you answered it. Clayton
Okay.
answered it.
All right. All right. So this picture right here is a globe with all of the water removed. All right. All of the water on plants, including oceans, is that big sphere right here over the western U.S. Kind of
It's
centered on Colorado. So that's all the water in our oceans and all of that stuff. It's about 860 miles in diameter. All right.
That's today?
Just always. We've never lost water. We've never gained water.
Wow, that is not a lot.
No, it is not. And that's in saltwater, freshwater, everything. So this little one right here that's kind of just below Michigan is freshwater in the ground, lakes, swamps, and rivers. All right, that is about 169 miles in diameter versus 860. And this little one right here, kind of over Georgia, that's, like really tiny. There. That is all the freshwater lakes and rivers, about 34 miles in diameter. So, and that little dot is really what we're working with drinking water. So there's not a whole lot. So we've got to keep clean what we've got. So if you've ever heard of the Flint, Michigan water or things like that, when we contaminate our water sources, a lot of bad things happen, and there's not a lot of other places to go. All right. I don't know how you guys want to put that on your packet, or maybe just type below it, like the biggest thing. Oceans are 96.5% of our water. Okay. That means that's all salt water. We do have some saline lakes, like Salt Lake, and saline groundwater. It's typically called brackish. Oftentimes it's near salt water and near a freshwater source, and they kind of mix underground. So that's what that is. And then freshwater is 2.5%. Now, we're going to break down that 2.5%. Like I said, you can just write the biggest and like salt and fresh, I guess. All right. All right, so when we look at our fresh water, all of our fresh water we have, the 2.5% of it, 30% of it is in the ground. That's your aquifers and things like that, like the Ogallala Aquifer that we get some water from. Then another almost 70% of it is held up in glaciers and ice caps. 70% of our fresh water is in glaciers and ice caps, meaning that 1.3% of our fresh water, so less than 1/100th of a full percent, is surface water. So that's your lakes, your rivers, and streams and things like that. So as big as the Amazon River is, and as big as the Missouri River is, or Mississippi, those are literally almost nothing compared to the rest. Yeah. Huh? Yeah, that won't do us very good. Okay, you're welcome. Yes, we don't need Florida. We don't. It'd flood Maryland too. Maryland would be gone. No, Maryland sucks. That's why I moved here. All right. So I'm going to back up for 1 second. We have that 1.3% of the 2.5%. There's some math for you. So out of that 1.3 of the 2.5%, this is how it gets laid out. I told you guys you don't have to write the whole thing down. Apparently. All right. So out of that surface water, at 1.3%, 73 of it is your typical ice and snow. So not glaciers, but like what gets put at the top of Pikes Peak, like we're supposed to get this weekend. 20% of it is lakes, like the Pueblo Reservoir. And then the rest of it gets broken down ridiculously tiny. So you have 3.5% in soil, just the moisture of the soil, 2.5% in salt marshes and swamps, less than 0.5% in rivers, biological water, which is just kind of a catch-all term for everything else on land. And then atmospheric water, so the water vapor that you're currently breathing in right now with or without a mask is still always there. No, please don't. All right. So with all of that said, only about 0.02% of the Earth's water supply is available to us as liquid fresh water. Even then, we would still have to process it in order to make it drinking water. So yes, water purification, or like I mentioned yesterday or the day before, reverse osmosis. So water is very political. It's actually even very political in Colorado itself, just because of water rights and mineral rights. Just because you buy a piece of land doesn't mean you actually have access to it. And so here's kind of a map with some research done behind it. Water wars to be fought. So notice you have a very high chance in your hotter desert areas, India, Northern Africa, things like that. Water is very sparse in the mid-US. We have our Ogallala Aquifer and our surface streams, and that's really it. Ogallala? Ogallala Aquifer, it's the biggest aquifer. It kind of does sound Hawaiian. I don't think Hawaiians have G's though, do they? I don't think Hawaiians have G in their alphabet. But so Ogallala Aquifer is the biggest aquifer in North America. That's where we get a lot of our drinking water. So when you see on those little water bottles that are like filtered through, 100 layers of whatever, it's all garbage. They just pulled it out of the well that everyone else drinks from too. But this gives you an idea of the first areas to go down if water starts becoming an issue, drinking water. Because we're awesome. We're humans. So actually I had one of my AP students last year build a, what are those called? The solar things where it collects the water. But he didn't do very well, and so he didn't collect very much water. But he did try. Yeah, A for effort. There's kind of a generic everyday. This is probably one of the more intense ones. I don't think you'll run into one this crazy when it comes to any testing. But usually you don't see like fog drip and stuff like that. Yeah, not that kind of drip. All right. I'm going to have you guys do that on your own. You literally, well, actually, I don't even have to because you have the answers. Huh.
Thank you.
So take a couple minutes and at least get some of those down. Like I said, I am going to try and move on and push through all of these notes today so I can get you started. And you guys, this is on I updated the PowerPoint on Canvas too. So the PowerPoint on Canvas does have all of this. Oh my God. Y'all are goofy. So as you're writing, I am going to talk a little bit because, you know, that's what I do. Transfer is all about location change. So it's not changing form. It's not going from liquid to solid or solid to gas, anything like that. It's just movement of it. Transformation is that phase change. So it's going from solid to liquid or solid to gas or vice versa. That's like your condensation or your, actually, oh yeah, sublimation is on there. So climate change effects, and I have a slide on this a little further on. Precipitation increases or decreases depending on where you are in the continents, which can create droughts or can create flooding. You get the sea level rise, like you've probably heard before, and like, you know, getting rid of Florida, getting rid of Maryland, part of New Jersey, all of that stuff with only like a six inch ocean level rise. All right, other human effects is you get the pollution, the chemicals, the toxic metals, endocrine disruptors, which means it screws with your hormones. I know there's a big issue in the Columbia River, kind of by where I grew up. There's fish that are being born, and hundreds of fish that are being born both genders because they don't have the right hormones, because there's so many drugs being diluted into the rivers, and then thermal pollution as well. Thermal pollution is also where you get a lot of the issues with the melting glaciers, both genders for fish. And so because they're both genders and they don't have the right hormone for fish, yes, there's two genders. Yeah, so that's okay. Hey, better to learn now than later on. So there are fish that can, like Nemo, for example, from Finding Nemo. So he can actually change genders. That is their biological process. They can change genders. It's not common, but they can. So like if you put a, yeah. Mm-hmm. Yeah, there's still males and females, like guppies and everything. Yeah. A lot of times, so humans are like the only species where the females dress up. Usually to pick out anything, whether it's like ducks or fish, anything like that, it's the males that are super vibrant. They have the bright colors, the flashy, flowy tails, or whatever it may be. And then, yeah, the females are really dull. I love watching the little bird mating dances. They're always so funny. They're like, they spread their wings and like do a little dance. All right, I'm gonna move on. If you need to write more, you can. Like I said, it's online. Important water vocab. So this goes in your boxes right below. And they go in order. Yep, they go in order. Aquifer, artesian well, confined aquifer, groundwater, surface runoff, unconfined aquifer, water table, watershed. Basically everything but surface runoff deals with underground water, and watershed just includes both. And we're going to go through what they are in a second.
Why does that pond make orange that looks
Yep, goes in order. At least I think I put it in order. I know last year I had it out of order, so I hope we'll find out.
We'll find out when we catch it.
Well, I'm going to give you all the definitions in a minute, so if they don't match up, I think I put them back in order, though, when I was redoing this. I think. We're about to find out. What about what? What'd she say? Worms? Oh, okay.
Worm? I thought it was worm.
Worms.
Where's the E? Where's the E? Worms.
Worms? Yes. I don't know, it's English. It's not worms, it's worms. They are asexual reproducers for the most part. So that means like you can cut it in half and they'll just go along their ways. And they'll each be their own individual. Mm-hmm. You're good.
Worms are blind. How are they supposed to be getting in when they're blind?
Where did I put my whiteboard marker? I forget. Anyway, I have them in that cabinet that says air pressure and wind. Oh, there it is.
A centipede? A millipede? Poisonous in the sky.
I know, I was going with the centipede and millipede. Like a pincher? Well, I'll have to think about that. I'll have to think about that. All right, so I'm going to go over these definitions really quick while I figure out what Ashley was drawing on the board. So groundwater, that's precipitation, so rain that infiltrates through the ground and is stored in soil and rock. So that's all groundwater is. It gets stored down here. Surface runoff is water that does not sink into the ground or evaporate into the air, and it tends to run off into streams, lakes, rivers, that type of stuff. So it comes down, it rains, not all of it soaks through, and it runs off. Watershed or drainage basin, I'll show you a picture of our own local one here in a minute, but it's like Earth's bathtub. It's the area that delivers any of that runoff into a main stream. So like we drain into the Mississippi River. We'll get there. A centipede? I did not know they were poisonous.
Not all are.
Mm-hmm. There's no hydration. Well, are you talking like liquid Kool-Aid, like, or the powder? Yes, the water from it will evaporate and it'll leave behind the mix. Yeah, that's how you can get, another way to get fresh water from salt water is let it set out in the sun and put like plastic over it, and then it evaporates the water from the sediment or from salt water, and so that plastic would then have drinkable water on it. All right, everybody's learning today. Okay, so underground caverns and porous layers of sand, gravel, or bedrock through groundwater flows is what an aquifer is. There's a confined and an unconfined. So your confined is below some sort of impermeable layer. Your unconfined is one that is able to move the water a lot faster. All right. Water table is basically the level below the ground that is saturated with water. So even if you live right up here in these pretty little trees, you are on top of water. It's just that the water table is below where you live. Now, it tends to rise or tends to meet that water level or that water table when it comes to lakes. Pretty much. Yep. There's your unconfined and confined. Unconfined with permeable, so that means water and oxygen and things like that can move through it. Your confined is kind of constricted by an additional boundary, usually like a clay, just because it's so hard for anything to move past that clay layer.
Miss,
Like semi-permanent.
can you go back
I
for a
mean-
second, please?
I have no idea what he did. Oh. Maybe. I know. This is the longest set of notes just because there's so many freaking cycles. It happens. There's, all right, there's this too, some aquifers are replenished by rain, some are not. Some of them need to be fed in through lakes and stuff like that. Oops, yep, that was right. Artesian well is basically pressure from the confined aquifer pushes it up. So you drill down really deep below that clay layer, and then the pressure down here is so tough from everything above it that it actually like squeezes water out like a sponge. And so that's, huh?
They're in different areas because look at the artesian well.
Oh.
The third one on the list.
Okay. It's up there, yeah. How watersheds work, like I said, it's just a really big bathtub. So here's Colorado Springs right here. Water drains off into the mountains down this way, so it heads this way. Out towards this area, it'll drain in, and it all drains down here. What is this right here? Anyone know? It's right next to I-25. The green. See how it's way more green right here? It is not the Sahara Desert. Oops. Or the Gobi Desert. It is Fountain Creek, people. All right, so Fountain Creek is, we're in the Fountain Creek watershed. Because all of the water that rains in this whole gigantic area drains out through Fountain Creek. And just kind of another visual of it on a different map. These are all your rivers in Colorado, so not your streams, just your rivers, along with elevation. So brown is very high, that's in meters. You have like Pikes Peak, where is that? That would be the San Juan, so Pikes Peak's probably this one right here. And then so on to the flatter areas. Different drainage basins. Ours feeds into the Arkansas Basin. And then just kind of some more maps and a whole bunch more diagrams. Oops. All right. There we go. We're not to the nitrogen cycle yet. So this is kind of a repeat of earlier. I think somebody had asked about like how climate change affects things. That's this right here. So you get more or less precipitation depending on where you are. And then the flooding or drought, depending on whether or not you get that more or less precipitation. Some places are going to get absolutely dumped on, while other places don't get half the amount of water that they need. Increased irrigation means they need a lot more uptake. And so you're going to deplete things like the Ogallala Aquifer. There's not going to be anything left. Oh, Leland.
Huh?
It's Leland typing.
I wasn't typing.
All right, I'm gonna move on. Well, actually, hold on. Yeah. This is one of those things, like, I'm way behind schedule in my mind, but this is nothing I can skip over. So it is what it is, I guess. So we're done for today. Yes. You won't be able to do the DOL that's listed because it's on nitrogen cycle, and that's the next one that we will do, I guess, first thing tomorrow. That one will be a lot quicker, and then I'll throw you guys into a cycle or a game with the ammonification and all of that stuff. So it's definitely not 2K. It is not racist.
Dollar bills.
Are you gonna be here after school?
Yep.
I might come.
Okay. All right.
Yeah, what do you